Welcome to my YouTube channel Mechanical Magic, Mechanical Learning Tutorials. So in this video I am talking about compression at constant temperature, and that will be from the adiabatic process. So let us see which kind of data is given from that problem. So here, determine the work done in compressing of 1 kg of air from a volume of 0.15 meter cube at pressure of 1 bar. So here the mass it will be given to us, and that will be m is equal to 1 kg of air, and volume, that means V1, 0.15 meter cube at a pressure, that means V1, 1 bar. So it will be converting into Pascal. So 1 into 10 raised to 5 Pascal. To a volume of, so that will be the second condition, or you can say V2, so 0.05 meter cube. When the compression is isothermal and adiabatic, so here it will be two different processes is given by the data, and take gamma equal to 1.4 and also comment on your answer. So just you can see, initially for isothermal compression process, or you can say constant temperature process, for work done determining, so work done that will be equal to P1 V1 ln V2 upon V1. So just put the value of P1, and that will be 1 into 10 raised to 5 Pascal. V1 0.15 ln V2 upon V1. So all the data is given from the problem, and you will identifying the work done at constant temperature process, and that will be minus 16.48 kilojoule. But I want to draw a PV diagram, so I want to find out a P2 pressure at constant temperature process. So for here, P1 V1 upon T1 equal to P2 V2 upon T2. So for the constant temperature process or isothermal process, T1 equal to T2. So P1 V1 that will be equal to P2 V2. So just put the value. So P2 equal to P1 V1 upon V2. So finally you will get P2 equal to 3 bar. So just you can plot onto the PV diagram. So x-axis that will be the volume, y-axis that will be the pressure. So here it will be the point number 1. So you can say initial, and isothermally compression. So 1 to 2 process, or you can say at constant temperature compression. So PV equal to constant over here. So that will be having a P3 temperature. Now for the second conditions, or you can say if the same system for the adiabatic compression, so what happened? So from the relation of the volume and the pressure, so V2 V1 that will be equal to P1 P2 raised to 1 upon gamma. So finally P1 upon P2 that will be equal to V2 upon V1 raised to gamma. So just put the value of P1, and that will be 1 into 10 raised to 5 V1 and V2, and also gamma that will be 1.4. So you will get the answer of P2 for adiabatic compression process, and that will be having a 4.66 bar pressure. So that will be higher from the constant temperature process or from the isothermal process. So similarly, point number 1 to here, point number 2 dash, and that will be for the second point of adiabatic process. So that will be having a higher pressure. So here 1 to 2 compression. So it should be said that PV raised to gamma equal to constant, or you can say adiabatic compression process. So adiabatic compression process work done that will be equal to P1 V1 minus P2 V2 dash, and that will be equal to gamma minus 1. Just put the value over here, and W, that will be equal to minus 20.75 kilojoule. So now we have all the value of work done for isothermal process and for adiabatic process, and also you can study the PV diagram for both the process of isothermal and adiabatic process. So from the data, what we conclude, work required for isothermal process is less than adiabatic process, and it is also seen from the PV diagram. So from 1 to 2 process, you can say work done required for isothermal process is less than of the adiabatic process. So that will be having a minimum pressure in the case of isothermal process. So thank you very much. So if you like it, then subscribe and share.